How are you today?
Good. All right. So I will do. Yeah, I just didn't know who was gonna say. Just
Are we ready? All right. All right. Hello and welcome to 94th Dev Club in English in Estonia. The first one in 2024. Uh, so glad to see you after a while. And for today's agenda, we have two talks. Um, that we will be holding today. So one is by Wise's very own Daniel Anyos. Uh, he will share his experience of being a product engineer at Wise, and then another one from Anton Gex, something blockchain related. No, not really. So it's basically, actually, if you've seen the announcement. Online on Devclub.ee or in the email invitation. So it will be a talk on the productivity and breaking through productivity hurdles as a software engineer and in software engineering or software development process. So a few words about our supporters. They're really awesome and they're really great. You will see them on the screen in a bit. So there they are. Also, special thanks to Wise, of course, for being such a great host for the fourth, maybe fifth time already. So hope not the last time. Hopefully, many more to come. And we're always happy to be here with Dev Club. And I think this is it with the intro, and I am going to invite Daniel on stage. So let's give him a warm welcome.
does it work like this, or is it better like this? Okay, awesome. And I have one more secret tool here. Let's see. So, hi, my name is Daniel. I work in Wise for almost 5 years, and I wanted to explain how is it like to work in Wise, because it's a bit mysterious, maybe, especially this thing about product engineering. And maybe, especially people are like, so what are you actually doing there? Hopefully, after all this talk, you'll have a picture about how is it to be an engineer at Wise. So first, just the quick intro. We're gonna talk a bit about what Wise. I hope everybody knows what Wise is, but we're gonna do a quick refresh. Then we're gonna jump into the topic, talk about feedback loops, then how they work in Wise, and how they work at scale, like how we make it work. So Wise started in 2011 with the vision to make international money transfers cheap, fair, and simple. So this number is interesting, 2011. It's coming next. And the mission is money without borders. They're trying to build the best experience for managing the world's money. Like, and I don't know if we're gonna show a bit. I don't know if you like. We used to be transfer wise, so transfer focus, but now besides that, we also have the Wise account, so we can store money in different currencies. We have Wise for businesses, and there's a whole team focused on making your business life at Wise better. And we have the Wise platform. So you might be using Wise if you do have accounts in some banks or some other platforms. Even though you don't feel it, those transfers will be processed by Wise. So Nubank, one of the biggest banks in Brazil, just signed a partnership to use the Wise platform for their international transfers. So this is like the latest additions to the Wise products per se. And yeah, you can see a bit of the scale here as well. We have more than 5,500 employees, and like all those licenses on the bottom there. And so all the engineers are deeply aware of all these flags and all these numbers, like these 7.2 million active customers, and how to make their life better, and how to make the increase the cross-border volumes, like currently 5% of all the whole cross-border volumes go through Wise. So yeah, how do the product engineering try to improve this? If you think about around this 2010, 2011, in some companies, not all companies, how would a traditional work maybe happen is like, yeah, you have your customers, they want something. You have a person that understands the business and they'll map something. You might have a product manager that will create the project and create the tasks. You might have the engineer in the middle doing some work. This work might end up in the QA hands. And this, after all the cycle, maybe with more people in between, this might eventually end up in the customer's hand or not, if it's not shipped. So the focus of this product engineer role is to try to shortcut this feedback loop, try to focus on creating a great product for the users and focusing on the bringing value, not just making, I don't know, adding code or making new features, but focusing on identifying and measuring and delivering the value for the end customer. And so that's why the last bullet point there is very important. Like the product engineer cares a lot about the user feedback and the usage data. A lot of data analysis and metrics is part of your day-to-day job. And how do we do it in Wise? This is from a blog post from Harsha. So we try to set up teams that are empowered and independent, and they focus on one specific problem. From the example, like in the past, like let's say that your team is focused on the business. You will have a set of KPIs or I'd say metrics that you think about it day to day, how to improve it, regardless if you are like, which area of the team you're working on. And we hire, we onboard, we train smart people and let them try to solve the problem. Especially interesting is this idea of weak code ownership, because sometimes to solve the problem, you have to tackle, like work with other teams, other products, other areas, and nobody's gonna be like very against your solution if you show what you want to do and prove that it will bring value. Again, yeah, focus on customer impact. Whenever we have a decision to make and you have to, okay, let's change this, let's update that. We always try to focus on how does this affects the customer. And if something doesn't go right, like if something goes wrong, we try to have this honest, blameless post-mortem culture. And eventually things goes wrong. So our focus is first, solve the problem. And second, learn from it so that we don't repeat the same problem again. So we try to work fast and try to improve things. Sometimes it doesn't work as well as expected, but we try to learn from our mistakes and try to, avoid failing the same way. And yeah, that's why I wanted to mention a bit about the feedback loops. And from the talk from Anton, I got a reminder. If you worked with IT, you might remember that the Agile Manifesto came back in 2001. And there was a very strong motivation or push towards this idea of feedback loops, like responding to change over following a plan. So trying to learn and improve, inspect and adapt. But maybe that was focused a lot on the engineering domain back then in 2001 and like back in the beginning. But in 2011, this book came out called The Lean Startup. And this was an attempt to bring the same type of values, like this fast iteration and inspect and adapt learning, to the business domain as well. And you have like these ideas, like there's two big ideas in this book. There was this build, measure, learn loop. So you wanna do something. You think about what you want to test, experiment, learn. You build the minimum thing that can validate your idea, and then you evaluate. Did you learn something? Did it fix the problem you want? So you try to make this loop as fast as possible with this second big idea that was the minimum viable product. And back then, at least in this book, some of the examples of this minimum viable product were like, okay, make a landing page. Just put like, no automation, no nothing. Nowadays, when you talk about MVPs, especially if you already have customers and they already, have some kind of expectations from you, you try to avoid making the bare minimum functional solution that might not be reliable or that might not be very usable. You try to slice your problem in a way that you can deliver the minimum functional solution to validate one idea that is also reliable, usable, and has a good experience for the customer. So that was a presentation that we had internally, but also if you search about this definition of the MVP nowadays, there's a lot of presentations on this topic that just doing this bare minimum might not be enough depending on your context and on your customers. But again, you still can split your problem in small chunk and deliver that first. And WISE coming up, being created in 2011, most probably was impacted by this book and this kind of movement that was happening, trying to deliver value fast for the customers. So how do we get those feedback loops in WISE? One way that we get feedback from the customers is in our mission. As a company, we present our earnings every quarter, but we also have every 6 months, we get together, usually in Tallinn, but I think the last time was across the world, actually. The whole company gets together and talks about, okay, where are we right now in our mission? How are we with the speed? How are we with the cost? And how can we improve it? And it's kind of interesting because people will be showcasing okay, here's a project that improved speed by 10%. Or here's a problem that is affecting our customers, 30%. They'll be talking real data about things that are happening last month or things that will happen next month across the whole company. So it's kind of like a reset about, oh, where should we go? How are we right now? And a lot of this is also available online. If you search for this mission days, you can find videos of it in Vimeo or in Facebook Live. I don't know if all of them are available, but a lot of this information is there. One of the values of the company is transparency. So the company tries to get feedback from the customers and from the clients this way, very actively. And every team listens to all these things and try to put it in practice with some projects and some product changes that we're going to be doing. And how do we get feedback from the customers as well? Not all, but many of the products and projects that you're going to be doing will have some aspects of feedback directly from the customer. For example, you're going to change some flow. You're going to maybe do some A/B testing or some feature flag rollout to evaluate, okay, is this working? Should we stop and update something? Another thing that is basics is constant monitoring. Maybe you released last week, but this week, there's no data. Users are not using it anymore. Is it working still? Should you go back to the engineering board? And we also get a lot of direct feedback from the customers. There's this technique called the Net Promoter Score. That's actively used by many teams, but we also just talk to the customers. We make interviews with them. We bring them to the mission days, for example. And we try to get fast and direct feedback to the customers to improve the products that we're making. And so this is as a team how we get feedback from the customers or from as a company. But what about your team itself? how do your team get some of this feedback? One way that we use a lot in Wise is if you want to make a change and if you want to make a proposal, you write it down and you share it with other people. We used a lot this architectural decision record, this ADR process, but it's similar to this RFC that you see in the internet protocols. It's basically, hey, here's the problem, here's the solution, here's the idea, and you share it around and ask for feedback. And people will be just commenting in your proposal or say, no, looks good to me. That's like, as you start, as you have your idea, we more or less always start with something like this before we start changing anything. So we get a bit of feedback from your own team and from other teams this way. And once you have an idea and it looks solid, we go to the team planning stage. Every quarter in Wise, we have these quarterly plans where we have a collection of ideas that are prioritized within your team. So anybody in your team will be able to provide ideas, and all the ideas will be evaluated fairly, like transparently, and based on the impact that this idea will have, on the confidence that you can deliver this idea, and on the easiness of implementation, like how easy it is to implement. And okay, we've done the planning, we have a list of projects. Oh, good, can we start? Not yet. So we send this list of projects for the tribe feedback, and they'll give feedback to you again, like, hey, okay, why you're not doing this? Did you consider that? So you get feedback from your team first, and then you get feedback on your plans from the other teams. And at least once per quarter, you get a feedback on the whole process. Like we have retrospectives every quarter, and they are part of the plans as well to say, okay, what did you do? How did you learn? What didn't work? Like, how can you improve? And those are some of the ideas that we use every quarter to get feedback from within your team and from outside your team. And one last thing that we do, we also try to get feedback as a person. So you have the company level, you have the team level, and you have also the per people level feedback. We use this concept of 360 degrees feedback called Grow Wise. I think a lot of companies use it as well, but here we call it Grow Wise. So twice per year, we ask feedback from everybody that you worked with, your boss, people from other teams, and they would honestly say, okay, I think you did good here. I think you have to improve there. And this will be shared back to you. And you'll be the person responsible for taking this feedback and changing. So like, this is not a feedback for your boss. It's more like you as a person, as you're growing in your career, will listen to the other people feedback and make a plan how to improve, where to, like how to grow and where to improve or where you're doing well. And you will be driving this improvement yourself. So that's an interesting approach that is like, there's a lot of transparency, and we try to be data-driven about it, like on the projects that you did with examples and metrics, that also on the people evaluation. Okay, so I explained a lot of things, but like, how does it actually work? And let me see the time. Yeah, okay, good. So, so this is like, there's a blog post from another lead that she wrote exactly about like the challenges of working in these autonomous and empowered teams. So for example, one problem, if something is wrong and it's not your fault, but I don't know, somebody broke something, it's up to you to fix it, you own it. So, and if you're focused on your problem and your product, you might lose track of what the other teams are doing. This is another big challenge that we have here, because we're like focused on the delivery and focused on your own numbers. And this might even cause a mess on the code level, because okay, maybe you have some quality standards on your team. The other team is focused on another thing, and the quality is like falling behind. And we might even lose the big picture alignment if you have different teams working at different levels. And we try to solve this with different approaches or ideas. For example, we have like a strong platform team that tries to push standards for the coding and metrics so that every team knows where they have to go and how to reach there. Like, so they have some automated tests that say, oh, your service is missing this and that features. Your service is missing this library updates. And this platform is always trying to find these big problems that the teams are struggling with and propose unified solutions that can tackle them. I remember that I made an internal presentation about some Kafka problems that we had. The next month, the guys that were from the staff engineers said, hey, Daniel, remember this problem that you said? Here's a new library that solves it at scale. I was like, oh, wow. So the platform teams and the teams that are noticing this common patterns, common problems, they will come up. And if you see a problem like this, and if you can propose a solution that solves the problem for most teams, you will also be able to propose this. And yeah, we try to make to come together to fix problems that are common, and we try to learn from each other a lot. So we try to book time for those improvements as a team. And the biggest change that I see in Wise compared to the other teams is that all of these things that I was mentioning, those are the engineers that are doing. If you have to do data analysis, the engineer will be driving this. If you have to collect the feedback from the customer, the engineer will be doing this. If you have to come up with a solution for a problem, the engineer will be doing this. Nobody but you is the best person to actually solve the problem that you have at hand. But like you say, like, but I'm not very good at, I don't know, NPS, or I'm not very good at, I don't know, data analytics. You have a whole tribe of product people, analytics people, and other engineers that are there to help. So on the high level, the product people biggest impact is not doing the product itself, but helping the engineers to do the product decisions in a smart way. For example, I think there's a link in the comments about one of our senior product persons, how they teach the engineers how to use KPIs, using KPI trees to try to prioritize the problems and the solutions. So that it's not the product person teaching, telling you what to do, but it's the product person teaching you how to think in a product way. The same thing with analytics. I was very bad at analytics before I joined here. And by working with a lot of smart people, they were teaching me their mindset and their tools and their solutions so that I can myself do most of the thinking and analysis, and also work together with them to deliver those analyses that need to be done or the ideas that need to be done. And the same thing with engineers. Like, you might have some experience with like front end, you might have some experience with backend, but you will partner with some very smart people that know very good about Kafka or very much about iOS, and you can get things done by partnering with these people and driving the solution yourself. And there's a new addition to this, how do you say, skill set. There is the data science team. This is so new that if you go to our Wise careers page, you don't see that yet. But these are like a Swiss knife person. The person, like, this is from the job ad that I found online. The person has to be very good at programming, very good at machine learning, very good at data science and data analytics to find insights, but also very good at communicating this and presenting this to other people. And also be proactive, be self-motivated to push things forward. So if you have a very tough problem to solve, you partner with a data scientist, and you get things done at very fast speed. And I'm not like, I'll leave some time for questions, but I wanted to bring one real life example of one type of problem that we solve in my team, and how do we think about this product, like this product engineering mindset. So we want to develop a new feature, it's like a new data point that will improve our machine learning solution. This machine learning has to look at this picture and I don't know, find the bad guy there. One example. So first, there's a lot of extra work to build this feature. How do you get this feature from the customer or from the environment where you have it? There's a lot of like thinking from the product side, but also the engineering steps to build it and to keep that thing working. But then you have to do the discovery, like which type of feature would actually help you and what would be the best investment for, like which type of feature would pay off faster. And that's usually the data scientists are better suited to do it, but you definitely can say, look, we have this and this and this, and they'll show them where the data lives. So you work with them and you get like a couple of ideas. Next, the engineering team will do some, I think we would call that data engineering, by building pipelines and making sure that in production at a reasonable speed, you would have these features being provided to the machine learning model. And you say, okay, done. That's it. Let's close it and go home. But like, actually, you have to do some steps like documenting and maybe some like monitoring. Okay, is the feature actually being sent? Are you sending no's now? Like do you see the data? You have to add also monitoring on the model side. Like, is the model better? Like you thought it would be better, but is the model actually behaving like you predicted, or is it drifting over time? So you put some extra effort there as well. And then you repeat the cycle. Okay, like, yeah, I'll build another feature set. So you go back and again, and then you think, how can I make this whole process faster? For example, if I have to validate every feature every time, maybe I create a feature alignment process that runs in the parallel, and that kind of like just saves me time. Or maybe if I'm going to be building several data pipelines, maybe I migrate to a new pipeline infrastructure. So you try to apply some thinking on the whole process so that, okay, next quarter, if I'm going to do more features, it will be easier and faster. And you keep iterating as long as you have time and it's bringing the value that you expect. So I remember somebody was, so what are you doing? What I'm doing a bit of the feature discovery. I'm doing a bit of the building of the feature. I'm doing a bit of the monitoring. I'm doing a bit of the analysis after that. So the product engineer will be doing most of it. And also driving this. So, okay, next quarter, which features do we want to do? Thinking out which type of features could help and proposing this for the rest of the team. So yeah, that's more or less what I wanted to explain, how we try to make product engineering work in WISE at the scale that we have. Any questions?
Yeah, thank you for your presentation. Really awesome. I have a question like around how are you applying the ICE model? Like, are you do like some examples?
So it's interesting because we always, like every team applies it to their context. Or context, we have another word there that is, we use RICE. So the extra R means different things in different contexts. In our context, it means risk. So, and we try to set the parameters, like because how do you measure the impact? For example, one easy way to measure impact is money. Okay, how much money would this feature bring? Sometimes the feature is not about bringing money, but reducing cost. But still, it's money, so you can correlate. But okay, but this is not to bring money or save money, but make things faster. Then you have to, are you going to translate the time to money? You can, but it's harder. But so we try to come up with some kind of set of metrics before you start measuring, so you don't bring bias to the evaluation process. The same thing about the ease of implementation. I try to ask my engineers, like, how much do you think it would be to build this thing on the top level? Like an estimation of, and we validate with the other people, say, okay, must it make sense? Yes. So it's not a real estimation or anything, but we use this approach, but we have, depending on the confidence level, we might have a better estimate of this ease of implementation. And the confidence is even interesting because we try to do something that we call discovery. So all the ideas, they have some kind of different level of maturity. If you have an idea that you already run a proof of concept, if you already run like a test, like by hand or whatever, say, look, this actually works. I measure it by hand and I can save time. You have some level of confidence. And, oh no, I just had this idea, I don't know, let's give it a try. So your confidence is lower. And so we use different, like we have some kind of scale that we try to apply about the confidence level, about like, did you run experiment? Is it running in shadow mode? Like there's some kind of grading that you can use about the level of maturity of your idea. But then we apply the risk as well. Some things, if you don't do, there's a risk that you're gonna, incur in fines or like, lose a license of like, so the risk is even harder to measure because do you use the whole like worst case scenario outcome, or do you use like some kind of average, meaning like, okay, we won't lose all the license, but we might lose this license for one day. So like we try to come up with this measuring rules before we start and try to bring as impartial as possible this measurement process so that when we go through the list of ideas, you just, okay, do we all agree the risk is this? Yes. And then we just sort the ideas by the biggest sum or multiplication of all these elements so that we don't push for your idea more than the others to avoid being any kind of like bias on the judgment.
Thank you, Daniel. So let's go through a quick round of questions, if you don't mind.
Sure.
Yeah.
Yeah, thank you for the presentation. You've told that engineering teams are responsible or actually getting the feedback from the clients. Can you please clarify how are they doing it? What kind of tools are you using? Or
there's something called email. It's funny, but it's like you launch something, we got 10 more emails. Like, there's the number metrics about, we started getting way more emails from customers from this. And it's up to you to match, because like, depending on how, if you're not involved, you might miss some of these data points. Like it's in the middle of all these other emails that you're getting. So if you are making a change and you think, okay, this is gonna impact the customers, you can sync with the customer support team, say, hey, if you find an email that is about my feature, label with this, and I'll read all of them. That's one way I've done it in the past. We've done it. The NPS score, we have it, like luckily we have these platforms and we have it available at different times in the product usage. So I think you can even push it for some experiences if you build some customer-facing experience and you can like trigger that. But even if you don't, you're gonna have like the customers that you affected by your feature, they're probably labeled with this feature, the feature toggles. So okay, I've launched this product. and it's running for this kind of customers, like with this label. And I see this NPS response, and it's like, and you can read the NPS response, or you can just get the metrics as well. Some people like to use machine learning to get this sentiment. I prefer like going one by one. So it depends on the scale of the change and the feedback that you're getting. We do these customer interviews as well sometimes. If you have an early product, you will be like, you can do this, show to them and say like, before you launch it at all, or even after you launch, okay, how was it? So we actually, in every mission day that I remember, we had customers saying, hey, yeah, you had this product, I used it, I didn't like this and that. So they give straight feedback to you, like even negative, even though they're coming to the company, they're transparent enough to say, oh, I like this, but I didn't like that. I'm thinking, what else? I think we're very active on the social media as well. So if you see some noise there, they're like, we're not happy, we will listen to that as well. So it depends how your team thinks that the feedback will come, and try to prepare the launch and the monitoring for those areas. Does it make sense?
By themselves, all these channels, all this.
But so it depends on the type of change you do, and also we do have the whole customer contact team that will come back to you, say, did you do a change? Because I see something happened last week. So some people will come back to you, say like, something changed. So if you don't do yourself, and sometimes you do this proactive thing, like, hey guys, we're gonna have to do a change. This will increase contacts, and you tell them in advance, and they will prepare. But if you don't do that, then the other teams will come back to you and say, hey, I think you broke something, or like some people are unhappy, and they will come back to you as well.
Thank you. Let's pick another one that was one over there. So you can, Daniel, you can keep your mic, and
okay.
we'll pass mine over.
Yeah.
Oh, thanks for clearly describing your, work process in the house, or the details in the house. But what about the rival companies? Are you becoming a user for the rivals in applications, or?
It's interesting because, for example, for a long time, Nubank was considered a strong rival because we launched in Brazil 2 years ago, I think. But at the same time that we were launching we launched in Brazil, the team was trying to build this partnership because Wise has the set of kind of like, how do you call it, rails to build some type of transfers that the other partners can't. Meanwhile, Nubank has a very big penetration in Brazil market. And so there's some things that we can do and some things that they can do. And they managed to build this partnership. So it's interesting because I think if you look at the history of TransferWise, you might see that in the beginning, they were a lot against banks. But even this behavior changed. So like we are just trying to kind of bring transparency to the whole system. We point out the bad guys that are like increasing the fees and making the things lower than they need to be. But at the same time, we partner with the banks to improve the process for them, or even point out, okay, this partner is actually doing better than us. And if you go to these comparison pages that we have online, sometimes you might see some banks and some concurrents, they are faster or cheaper in some areas, in some markets. And we are also transparent about this. So I don't think, like, we try to keep it healthy in the sense, like, we don't try to completely just fight against all the competitors. We try to always build partnerships to grow together. Did it answer?
Yes. Ooh.
Yeah.
You talk a bit more about code ownership. You said one hand, that platform team is pressuring teams to maintain microservices. You have a lot of microservices.
Yep.
And second, other hand, you said that you have weak code ownership. So
And this comes in multiple ways. So for example, sometimes the platform team, they want to do some migration. And they'll say, hey, here's a bunch of 200 PRs for all the 200 microservices. I don't know if it's 200, just coming up with the number. You just have to review, test it, and release it. Sometimes they even build some infrastructure, say, hey, we already tested it for you, so it works, trust us. Or sometimes they'll just say, hey, there's like a service that shows, hey, here are the minimum features you have to use. So they say, no, you have to use this, please do it. One approach that we use as well sometimes, when the problem is like big and most teams have the same problem, we have something called squash days. It's like we book in a calendar, say, hey, this day we're gonna sit together and just do this migration across as many services as we can. So the people will be like together in the rooms and say, are you having this problem? Let's do it together. So they'll be kind of like pair programming, and everybody will be helping each other to do those migrations if needed. I'm thinking, for example, we had to do like, I don't think it was exactly this, but like similar to doing a Spring Boot migration that was very large from like 2.6 to 3. Then it's okay, let's put a day in the calendar. All the engineers will join from whatever office you have, and we'll do it together. Because like you see that the things are not moving, and so let's try a different approach, like a hackathon, but like during your work day.
To perform technical maintenance like that?
It works because like when I joined, so when I was stuck, it's like, I don't know how to do this. You go there, it's like, dude, I tried this. I say, have you tried that? Have you tried that? It's like, and then they kind of help you if you're stuck. And it helps you to kind of like put a time for it. Sometimes you're just like, I'm too busy, I'll do it later, And you just have it in your calendar. Okay, I'll do it. In those aspects, it helps.
Like a top limit, how many people can actually participate, so it still remains efficient.
Yeah, so it's kind of distributed. It's not like, because we have offices everywhere, it's like in the same day, but like people in Singapore, people in Estonia, people in Budapest will be doing like in different rooms, but like, and you come and go. So it was kind of like open door, like there'll be people doing there. You come, let's try this together, and then you can go back to work if you're done or something. So it's kind of like a push, but it's not also mandatory. It's just like a very strong recommendation to come and try to do it together.
Awesome. Daniel, thank you so much. Thank you, everyone. So Team Wise has prepared a quick office tour. So for anyone who wants to join, then Mara is over there with the office tour. There's also drinks and beverages and snacks in the show. So let's see you in. Did it?
being with us, and let's welcome Anton on stage with his talk on breaking on productivity chains.
Hello, great to have you here. So just a couple of words where it is all coming from. So Codeborn is a services company. I'll see if I can use the laser pointer here. I'm not sure. I think I cannot, unfortunately. That gives me an opportunity to see from the inside a lot of different projects. So a lot of different teams, how they work, what works for them, what doesn't work for them. So and here I have collected some of the productivity hurdles that that definitely usually impact productivity in a negative way. So let's look at them. So the microphone works weirdly. I don't know, maybe I should not be using it. So basically, yes, I will be telling you how to kill your team's productivity. So step-by-step guide. And what I see in many teams is that people actually do stuff very often. They take some practices only because everyone else is doing it, and in my opinion, you should always be questioning every productivity, every practice, every tool, every language, whatever you're using in software development and not. You should be questioning it. Is it something that you really need or not? So very often people do use a lot of stuff that they don't actually need. So it's all about the developer experience. So as you know, the developers should enjoy their work in order to be productive, in order to do good stuff. They should not hate their work, and it's very easy to make them hate their work. So it talks about languages, of course. In programming languages, which one you choose is really important, actually. It is so very important for the task. It's not like the universal choice. So in languages, there is a different levels of verbosity. How much do you have to type? How much do you have to read in order to understand what your language does? What is the level of abstractions? Is it right for your project? Then the tools, of course, the IDE. Where are you writing your code? Is it productive? So is it helping you? How is it helping you? Which version control systems do you use? Which issue tracking do you use? So I hate Jira with passion. So this is definitely an example of a tool that that actually gets into the way of doing stuff or understanding what you have to do. And of course, last but not least, are the practices and processes. What do you have? How many meetings do you have? What kind of reviews do you have? What is your responsibility and whatnot? So productivity and motivation are also like closely related. So work needs to be meaningful for everybody, not only software engineers. And people should see and feel the value that they are creating while working. So contra example here is that, for example, if you're writing code that this never gets shipped to production or is delayed and reviewed too long or whatever, that makes me feel sad because my work is not valuable. I'm not doing something important if nobody wants it on production. So you always need to be working on the important stuff right now, and that means you should be delivering it right now as well. So if you're not doing it, then you're not doing important work enough. And so the best recognition for software engineers, of course, is that somebody is using your software and they are happy. Like we heard Daniel speaking about the users like making transfer all over the world. That's a good motivation then, because you know there is somebody, you're making somebody's life better. And if you're just writing code for some service that nobody like deploys ever, then probably nobody is you're not making anyone's happy. So the next thing is easy versus hard. is that in anything what you do, not only software development again, you always get more of the stuff that is easy to do and much less of the stuff that is hard to do. And when choosing your practices, you need to always think this practice, what are the things it makes easy, and you will get more of them, and what it makes harder, and you will get a lot less of these things in your project. So it's also about the convenience versus inconvenience. So basically people do more of the convenient things. So if I have a glass of water standing right in front of me, I will probably drink it. If I need to go very far away for it, then probably I will not do it or as much. So yeah. So make valuable things easy and convenient in your team. So that is really, really important rule. So when choosing anything, what you are going to use. So we in Codeborn, we're also fans of Agile. It's a buzzword nowadays, but the extreme programming is something that we were practicing. What? It's better to use because, in my opinion, like. Okay. Okay, because like I hear that sometimes it's louder, sometimes it's less louder, but that's. Mm-hmm. Okay, that's cool. So so we're using extreme programming, XP values, and I will list some of the most important ones that we think like we value most, and that means that we need, with our practices, we may need to make these values easier, so we get more of them from our projects. So it's about quick feedback in everything, also what Daniel was speaking about. So it's really important on every level. From the engineering perspective, it also means that you should always work in smallest possible chunks as possible. So you do very small features that you deploy often, because bigger features are much harder to deploy. Then you go do small iterations, you do small commits in your code. Everything should be small. Then you do stuff continuously. For example, you continuously integrate with others. So basically everyone works on the most recent version of the code, not on own version of code. Then in the continuous deployment, of course, as I talked before, that is something that is makes your work valuable. Then collaboration is very valuable, that you talk to others and work together. Then and you should be doing only the valuable things, which are right now are the most important things, is meaning that, again, you need to keep things simple and you need to do just enough design. But of course, when you find that it's not enough anymore, then you like extract it, you grow it, you refactor it to make it like more suitable for the new needs. But you never do more that you need at the moment. Of course, automated tests is also one of the values that often is forgotten. They give you confidence that you're not breaking stuff, and continuous refactoring. And overall, if we talk about the lean software development, the message there is to eliminate waste. So don't do stuff that doesn't bring value. So let's now start with the more concrete examples. So version control systems were the very big and great innovation that happened to software development. Engineers in other fields still copy their files with different names, with dates and whatever, and then try to understand what has changed. So we have the privilege of having good tools, and they enable us to do the collaborative editing and change tracking and whatever. And if you have been in software development for long enough, probably you remember the older tools like CVS and Subversion, how much less powerful they were compared to the Git, which is now universally used. So I think I heard recently that in some survey people said that Git was the biggest innovation in software development in the last 20 years. So maybe I could agree with that. It's a really good thing. But where is Git coming from? It's coming from open source. So it's from the creator of Linux kernel. Linus Torvalds created it for his own need and for open source needs. And how open source software is being developed. Is being developed by a lot of collaborators from outside of your organization whom you don't trust. So you don't know who they are. Maybe they are malicious people, like the recent libxz backdoor, if you've heard about it. So there was a guy who actually just built the trust during 2 years and then committed some backdoors to the project so that nobody would see it. Fortunately, it was discovered. But this is where Git is coming from. So it makes easy things which are needed in open source projects. So meaning that it's easy to contribute stuff and leave it to marinate for the code reviews of people. Because if you're making some changes, you're not trusted, but somebody goes through your changes very precisely and only then merges them if they are like good enough. So also, of course, what we should be doing with the version control systems is that do the really small and related changes, group them together, and we should write good commit messages which respond to the why question, so that it is easier for us to understand it later, what we have done, why we have done it, and also for the reviewers who are actually checking our code. But it brings us this universal usage of Git, and nowadays almost everyone uses it also in company environments, in the trusted environments. Then a new practice has evolved that brings more problems than it is worth. So what is it called? So somebody. Pull requests, yeah. They are actually, so this is one of the comics about that actually when you rely on pull requests for your code review, and code review is a good thing in any organization because people do make mistakes. But if you use pull requests as a tool to do code reviews, then what happens? Then the developer who does the pull request thinks, okay, probably I don't have to do my best possible job because the reviewer anyway will check it again after me. And then the reviewer, of course, thinks that, okay, I'm sure the author knows what he's doing, so I'm probably not going to go into too deep into this detail. So basically, it doesn't work as people try to make it work. So pull requests, this is comes from open source model, and as you can see, that makes your simple road to the result not a simple one anymore. So you don't have one source of truth, you lose it, you just get into the whole bunch of parallel realities in your code, and you can never be sure what is the correct state of the code that you should be working on, and which one will actually stay. So that makes it a lot more harder to do good work. So the goals, the goals are very good, like code reviews and collaboration. And of course, there is always the goal of control when you're introducing pull requests in your team. But what you actually get is that you get a big delay of feedback, and in agile values we want to have shortest possible feedback. So in pull requests you can be like developing something for a week, and only after a week somebody will tell you that it's a complete crap and you need to redo everything. So that's a not nice situation. Then, of course, if you are brave enough to improve your code more than to do tiny changes here and there, then usually you get merge conflicts because your pull requests are still reviewed too slowly, and then once they have been reviewed, there are a few other pull requests have been merged that you have never seen before, and they have changed a whole bunch of code that doesn't exist anymore on which your code was based. So you're in another parallel reality now, and you have to redo some of your stuff by fixing the conflicts. So not a cool stuff. And like there are a lot of jokes can be made about the pull requests. Is that I think everyone who has ever used pull request can relate to this one as well. So you never get good feedback. So you either get too much of the nonsense feedback that is not that important, and very often the important issues get missed because when you do more of the code changes, nobody dares to like. Take their focus off their work and go and review your code thoroughly enough. So, yes.
Again, sometimes team find pieces of code in the code base that no one actually agrees to, and it's a mystery how it sleep there at all. And
Yep.
all these code reviews and checks.
So I think everyone has a lot of examples that pull requests don't actually do what they were intended to do, and they're only making the job of developers harder and make developers less happy. So if we go look at it in terms of easy and hard, so pull requests and Git and whatever, it makes it easy to make a lot of branches, so a lot of parallel realities. So it makes it easy also to hope that somebody else will find bugs. It makes it easy to make very few code changes because more code changes, you know that you're getting conflicts after that. So it also makes it easy, or people tend to try to fit all the new features into the current abstractions, because doing a bigger overhaul and refactoring of the code base when you know that the pull request will get too large and nobody will care to look at it. So in one of the extremes, it will get approved too easily, which probably would be a good thing. But another extreme would be that it will be just they're marinated for a few months because nobody has time to actually thoroughly review it. And meaning that you will get a whole bunch of conflicts during that time from other pull requests, who don't dare to make bigger changes, but only make smaller ones. So, and yes, it makes it very easy. The whole format of reviewing the pull request and putting the comments there makes it too easy to comment on unimportant things like the style things that are like more easily, obviously visible, and then they will make you return to it and fix it again, and then maybe go through the several review processes, again shifting your focus from the stuff you were working on back to the old stuff, and then back and forth, and this kind of back and forth losing of focus never gets good results. So but on the other hand, they make it hard to do the good things, like the Boy Scout rule. Who knows it? So few people. Stas, what is it?
You should leave the code base slightly better than you found it.
Yeah.
Always.
So for the scouts, it was about the campground. Basically, you arrive to a campground, you see it's like it's a mess. So somebody else left some trash. You just pick it up, you make it cleaner than you found it, and then you like. When you leave, then you find when you leave it even cleaner than when it was when you arrived there. You should do the same always with your code, because no code is ever perfect. And while you're reading code, I always have this habit. I'm always like changing it when I'm reading the code, because there will be somebody else reading it after me, and maybe I will be reading it after like some time. And if I find something hard to understand, then I better do change it right now, because I already spent some time understanding it. So I rename some variables, some functions. I can even extract some functional method while reading it. And I commit it quickly, and I forget about it, because these are really safe changes, but they make it more readable for the next person. So I just pick up some trash while reading it. But if I have a pull request at hand, then I know, okay, these changes probably will make the review bigger. Okay, maybe it will be delayed even more if I do it, or maybe they will, even worse, ask me to split the pull request to several pull requests. And this is like when you pour a milk into the coffee, it's very easy to do it, but when you need to extract milk back from the coffee, it's not a fun thing. And this is what the splitting of pull requests usually is. You had some question?
I just wanted to comment that probably if you commit something like this into a pull request, you will be asked to do exactly this.
Yes, yes, and that's a terrible thing to happen, and that's why it is hard. So people don't do it. So they stop tidying the code. They stop improving it every time, because improving the code becomes difficult. And the same is about refactoring. So basically, if you ever need to change the abstractions, you need to do some bigger changes and whatever. Again, if you do it in the same pull request, you are screwed. You need to like take your milk out. But when you, if you don't have to use the pull request, you just do it, you change it, you improve it. The others will instantly see your changes once you push it, and they can already take them into account while doing their own changes. So there won't be so many conflicts, or probably not any conflicts at all. So yeah, the review of bigger changes in Dev is very hard with pull requests anyway. So it's much better to actually review commit by commit without the pull request like umbrella. So, and of course, it's hard to manage and fix many unrelated branches. So, so you are just sometimes you have like 10 active branches still in review, and you have to go back to all of them and fix some comments. And then in the end, you spend, okay, my working day has passed. What have I done new? Nothing. I was just fixing my old pull request from a month ago. So not motivating at all to me. So more problems. So the reviewing process usually ignores commit messages, and commit messages should be very small and descriptive. So good commit messages, they respond to the question why. And while somebody is reviewing a whole bunch of commits at the same time, they usually don't go through the commit messages. They just look at the final result. They don't know how you have arrived there. And it means that probably they will ask more questions about your changes that already answered in the commit messages. And again, it will require a new like loop from you. So to return to it, explain, and then go back to other changes and whatever. So some people like to squash commits also, and squash commits actually lose very important history. So the same xset library compromise, the same person who compromised library xset during the 2 years, he has contributed to other open source projects, but many of his commits were actually squashed as part of some pull requests or whatever. So right now it's impossible to review the commits of this person in isolation, and because he had definitely malicious intents, it's a really big loss. So now it's much harder to analyze the whole impact of this person on different projects. And the same is in your company, your project. So if you're squashing commits, you're losing the history, and you don't know which things were actually done together and which things were done actually separately. So you just get a whole bunch of code changes that are impossible to reason about quickly enough when you're analyzing some problem, production issue or whatever, or just you have a question, where is this like code line is coming from? Why was it written? So I usually do the git blame. I see the commit message. I see the name of the person. Very often I can go and ask if I still have some questions. But with squashed commits of the whole pull request is much harder. So the developer satisfaction is low because they have to return to the stuff over and over and again. And new branches on older code base don't get benefits that already done. So for example, I have already fixed some functions. I've done some nice things in my last branch, and then I have to return back to the old unmerged master and create a new pull request from there. And again, I say, okay, why is this code still here? I already fixed it before, and I still have to deal with it again. And probably there is something that important that I have fixed, and I don't get this fix. So I get these problems every time actually when I worked with pull requests. So, and yeah, review comments focus mostly on style, not for of understanding, and most developers don't like also even reviewing the stuff because they take your focus away from you. So you are not bringing too much value when you're reviewing. So there should be a better way, and better way is going back to the roots, to the and no, it's not the artificial intelligence. So right now there are some products already on the market, like artificial intelligence code reviewers. Yeah, they will definitely be maybe quicker than your fellow coders, but they will still probably take your time with reviewing and getting back to them and whatever. Why not use the AI assistant right there in the code while you're still writing it, and not afterwards when you have finished your work? So mainline development is a solution, and it's getting back to the old stuff. And how do you use it? So this is, of course, this is for high trust teams, when people do trust each other. So if you don't trust somebody, then pull requests are the way to go. So these are good for the low trust environments. So, and how to still do the code review, because code reviews are still needed. They are still a good thing. So how we do it in like a little bit bigger teams is that we go through, for example, every day we open, like sit together, go through the commit history here. And we go through each commit made yesterday, for example, if we do it in the morning. If we do it in the evening, then we do go through each commit done today. And we review it, like the delay of the review is much shorter. It's like a few hours usually, and you can give feedback that people is still in focus. They still can go and do a fix or like react to the feedback if it's important. And like nobody gets too stressed, and of course the whole team can get see the changes, so they are get into the loop, so they know about everything that is happening in the project, and there are no just surprises just arriving as a pull request like 1 month after it was created. So, and of course, that also like brings the agile value of collective code ownership, is that also the collective code ownership is really important because there is no your code and my code. There is our team's code, and you are going and changing code anywhere where it needs changes, it needs fixes and whatever. So, and this kind of mainline-based development actually makes it easier and facilitates it, not makes it harder like pull requests. So if you really need to delay some features deployment, then it's better to use feature flags, because feature flags give you a lot more flexibility. This is the code. This is not dead code. So this is code that you still have. Everyone sees it. Then they develop new features. They still can take into account that code that already is written, even if it's still like disabled. Then you can enable it only for some customers, for example, for some users in production, not for everyone. So there's a lot more possibilities than just holding your code back in a separate branch that is never used, never tested, and nobody knows how it will affect like other branches and features. So, and yeah, Agile is about not working on unnecessary stuff. And that's why you're only working on necessary and important and valuable stuff, and that mainline development makes it easier to work only on valuable stuff. So if somebody asks you to create a feature that nobody needs, you usually, even if you are creating a pull request, you know that the stuff that you are now working on probably will not be needed for like another month or maybe 2. Then it's better not to work on it right now and do the stuff that is actually needed in production. And of course, pair programming helps a lot. So what we practice in our teams is that we do pair programming, and pair programming is like a code review, a real-time code review 100% of the time. So basically, you are sitting next to another person and they can comment in real time as you type. And that is the shortest feedback loop possible. And this is the actually best for the quality and actually enjoyment of your work, because you get feedback quickly, you get to talk to people, not only to computers, and overall, like it's much better for mental health and everything. So enough about pull requests. Let's go further. So do you know this place? So where is it? Where was it? Yes, it's correct. It's Berlin. There is now a modern city like this also. It's called Nicosia in Cyprus. Also an interesting place to visit. But this is, let's leave separation to unethical politicians. So what we want to do is that we want to stuff that changes together, we should keep it together. So this is again a really simple rule in software development that you should follow like on every level. So on the repository level, on like file level, class level, function level, whatever. So you always need to keep stuff together that change together. And if you separate, like the original thing was that if you have separate backend and front-end code repositories, it is a problem. And if you have even, if you split backend into many backends, that's even bigger problem. Yes.
As separate teams. This is even a bigger problem.
Yes, that's where I'm going to, of course. So so basically, yeah, you should never structure code by technical means. So inside of your backend code, there's often like different types of code that you write, like controllers, services, repositories, whatnot. And in some frameworks, like Rails, when it appeared, and that practice kept creeping over the software industry, is that you put stuff, you structure code by the type of the code they are writing, not by the really important things that should keep the code together, because usually controllers are quite separate from each other and they don't change together, but you're keeping them together in one folder. Why? So the same goes for the front end, back end, and API, apps, whatever. So you need to structure a code by domains, by features, not by technical means. And front-end and back-end separation is a pure technical difference. It's of course it comes from the over-specialization that now also is prevalent in software development, unfortunately. But it also makes it is possible to work like that with very narrow specialists. But of course, you will be just way less productive when you can have the same people just go and implement the whole feature from put some change in the UI, then change the API, then change the I don't know, repository, database, and you do it all in one commit, and you do it in like half an hour, and you commit it, and your continuous integration, continuous deployment, deploy it, and it's done, and you don't have to return to it. But if you have separate people working on the front end and back end, then you can never deliver any feature fast enough. You always need to be waiting and synchronizing with other people, with other teams, and you get a whole bunch of problems. Like a whole bunch of problems with versioning and this kind of stuff. So you need to track if your front end this version works with the backend of another version, or if you're deploying them separately, you can always need to ensure the backward compatibility, meaning that you should keep a lot of legacy code that you need to reason about. It gets in the way when you're refactoring, and so you are accumulating noise and garbage in your code, basically, if you're keeping these things separate. So, and yeah, and example how to structure code is like by users, payments, accounting from, for example, some banking application. So these are the things that change together. So everything that is related to user management, everything related to payments, whatever. So the solution is very simple. You just keep the stuff together. Even if you have people who are like more proficient in front end and others are more proficient in back end, you still, if you put them to work on the same repository where you have both front end and back end code, it still enables people to get into the realm of other people and do a small change there. And it will also facilitate learning. So they will become more and more capable of changing the other part that they are usually not the specialists in. and they will become more of the generalized specialist over time. So this is like there are a whole bunch of benefits there. And we know that in software development, you can never keep doing the same thing for years, because during my career, I have changed so many languages, frameworks, whatever, so it's impossible to count. And I never get stuck with only one thing. So I know that if I need to get the job done, I will pick the tools that I know right now, which are available right now and the best right now. So maybe next year there will be even better tool. So yeah, it's a lot more productive, even if you have also the mobile apps, which is popular nowadays, to re-implement your application at least 3 times, like the Android, iOS, and web. So you can still keep this code into the same repository, and that will also make you better understand which parts you need to move on to backend, for example, and not re-implement in every front end and do over and over again. So usages of anything are easily searchable if you have the single code base. So if you want to change something, you don't need to always create a new version of API. You just go and update all the front ends, especially, or maybe you can find that something is not used at all. You just delete it. It's very, very easy when you have only one repository. And yeah, refactoring is a breeze. So you do more of the easy things, and refactoring is easy now. So you're keeping your code much more clean and more relevant to the features that you have right now and to the stuff that I use right now. And here I also written that some people call it a monorepo. I think it's a wrong name. Monorepo is something very huge. It's something that Google uses apparently, where they have absolutely everything that they have ever developed in a single repository. This sounds a little bit crazy for me, because these things are not always well related. So you only need to keep things which are related to each other in the same repository, and the less related things you better keep separately. And that's how you actually make it more efficient. So you can have separate teams working on non-related things and the same team working on the related things. So that is a much better approach. So, and of course, as a bonus, when you're doing front end and back end together, you can have even a shared type definitions very often. So you have a type safety of your back end versus front end. So you never call an API that doesn't exist, or read a field from the request that doesn't exist anymore and something like that. Or you never type it wrongly. So yeah, it empowers the team to do changes anywhere, and reducing the track factor. So we had a couple of clients recently where I persuaded people to actually switch to the single repo, and everyone were so much happier after that. So like one thing to consider. It's not that hard actually to put 2 repositories together into one, and from the next day you will start getting the benefits. You can still build them separately, you can still even deploy them separately. You don't have to change all of that instantly, but you always you will be able to do a few changes, like the cross-cutting changes in both backend and front end, and write a single commit message to it. And then it will be so much easier to review these changes together and ensure that you are doing the right thing. Then number 3, lack of continuous deployment. So of course, I like the analogy of fixing the plane in the mid-air. So this is what we as software people do all the time if we deploy our code. So continuous integration, as I told you before, this is the practice introduced by Kent Beck in Extreme Programming book. It means that everyone works on the same code base. This is really hugely important, as I already explained before. And the continuous deployment is when you actually changes are not marinated for a long time. So when you actually roll out your changes and you get feedback from your end users, and you feel the value of what you are doing, and all kind of other very important things that I already explained. So continuous deployment, I've seen teams not caring about continuous deployment much, and you should definitely care. And this is also the way of getting feedback loop shorter. In our case, any project that we develop, it's always after each commit deployed automatically at least to a demo server, where every like stakeholder caring about the project can actually review the current state at any time. And there is only one current state at any time because we don't use pull requests. And that is important. So they can give you feedback very quickly and you can react to it. You can fix something very quickly. And then, of course, because you also have the tests and everything running all the time, then you are confident to deploy it to production also, because you are deploying every change and maybe once per day you can deploy it to production as well. So the next thing is that you probably recognize the situation. So very often, again, it's a solution to the wrong problem. So microservices. Why do people like microservices or they try to use it? Because they have seen this. And the big pile of shit is not nice. This, I think we all can agree with that. So, but if you have all these problems that created this big pile of shit here, when you like take the same people and same practices and split this into smaller piles, then you get the same thing, like just many of it. So this is usually what happens. So you always need to think about what do you, if you apply this, you need to do something really differently to avoid getting this picture here. So microservices is something that you probably should not be using unless you have maybe hundreds of developers and then you just need something to split responsibility. So if you have like a small team, like, I don't know, up to 10 people or something, and you want to make the same team responsible for like 5 microservices, that's not going to work well. So it will create, again, obstacles of people changing stuff. It will create more boundaries between, like artificial boundaries between stuff. So it will be hard to make related changes together. And if it's the same team working on them, it doesn't make sense at all. And especially, and you get all the minuses of inefficient deployment, because microservices always are much slower than something that the computer can run in the same memory, in the same process, and you will just lose a lot of time on the network latency, on serializing, deserializing data and whatnot. So in most cases, you probably don't need it. So you need it if you're big enough. Maybe Wise has good reasons to use it because of the 7 million users. Then you should split some of the things, but you don't need to do it wisely, because very often if you start your project as a small one from microservices, you will never do it right, because you don't know where the boundaries are, where will be the biggest performance problems, or how will you split your teams down the line, like after five years. So I know that Wise was started as a monolith, then it gradually started switching to services. Correct me if I'm wrong, but this is the way how to do it. Of course, you need to build your monolith not in this way, so it will be easier to split it later, because this one is not very splittable, and when you start like taking smaller chunks out of it, it still will not make the whole picture better. So yeah, and it's yeah. So there are ways when it is needed, but don't do it unless you really know what you're doing. And try, even if you're doing microservices, maybe it's a good idea to keep them in a single code repository. Because even if you're working only on one microservice or two, it's better to work on one. So then you will still see what others are doing, and you can do related changes together, and you will still can keep the collective code ownership, or like the weak code ownership, as we heard today already. So yeah, and with the microservices, usually what you get is that it's impossible to run them all on my machine. So testing becomes much harder to make sure that your code actually works, and like making the feedback loops and unreleases changes, and all these issues will start piling up. So basically, no more working software. So, and working software is one of the agile values that we have in the Agile Manifesto. So the like, yeah, I already mentioned some of the downsides. Yeah, don't forget about the climate change. So CO2 and more resources are needed once you split deployment of your code, and then meaning that you're contributing to using more electricity and faster climate change. So harder to test and develop the whole system, and don't forget about the backwards compatibility and version tracking. This is a really big additional work. If you can avoid it at all costs. If you want to be productive and more quicker releasing stuff. So it's a lot more work, yeah, to do the cross-cutting changes, because you need to change one microservice in a backward compatible way, then you go and change another one again in a backward compatible way, and maybe forward compatible way, and what's not. A lot of dancing and doing instead of the real work. And yeah, and almost always when I've seen people adopting microservices too early, they always have inefficient boundaries. So if you find yourself changing a few services during the same day or even same week, then probably the boundaries are not correct, or the team structure is not correct, or whatever else. But only after time, after learning your code, your functionality, whatever, you can really understand better how to structure your services if you really need to separate them. So there's, yeah, Conway's law says that your code will always need to repeat the structure of the organization. So you don't try to fight with it and create microservices that don't match your teams, because then it will not work efficiently. So yeah, the alternative is easy. If you want to get the benefits of microservices, usually why do people do them? Is to actually make code parts smaller for people to work and reason about. Then and also to prevent the dependencies like the spaghetti code from forming. So basically, you want the dependencies to go in a certain direction, not vice versa. So you just split your code into modules and you compile them separately. And in this case, you can enforce the dependency order. So you never will put wrong code, which is related to the, I don't know, your API, you will put into the domain logic accidentally. So that will reduce the probabilities of this spaghetti bowl from appearing. So you get most advantages of microservices and very few disadvantages, because you're not paying the price of separate deployment, and separate deployment and all that is a really high price. So deploy separately only when you have dedicated teams and really a reason from users that you really have to do it. Then number 5 is technical debt. So there are 2 types of technical debt. There is unintentional, when you're just writing bad code without knowing it, and without following the good advice and practices. And there is also in startups, it's very popular nowadays to do the intentional technical debt. What does it mean? It means that these are cautious decisions that I'm now not writing tests, not doing good stuff because I need to move fast. And what happens is that you move fast and then you break things. And when you break things, then everything falls apart and you spend a lot more time fixing it than making it good in the first place. Of course, you will never know the whole design and everything what you should do in advance when you're writing code, but that's where you have to follow the keep it simple and these kind of values, but never keep it bad intentionally. Keep it simple so that you can move faster, iterate, and then come back and add something there instead of skipping important things, like, for example, tests. So if you're not writing tests, your code will bite you in the end, and pretty soon. So nowadays, I really hope that you are writing unit tests and integration tests, all kind of tests, because hoping that there will be somebody manually testing your software and telling you where you have screwed up is not a good thing, because there is a huge long delay in getting this feedback. And probably if you getting your feedback from your end users, then the reputation of your software will go down significantly. So it's much better to write tests right away. So it's not hard to do. It doesn't take more time if you use it as a design phase of your code. So if you use it to design your APIs in your code, then you get tests almost for free instead of like writing them after you have already written your code. So yeah, then not enough refactoring. So if you use pull requests, you're usually not refactoring things, and things get messy very quickly. So you keep adding stuff like here, and the foundation waiting for the whole stuff to fall apart. And when you get to the situation of falling apart, you will usually approach your managers or your customers and say, hello, sorry, we cannot do any new features this week because we need to refactor stuff. And then the customer asks, well, what? And then you have to explain that you have done a really bad job in the last half a year, and now you have to fix it all in 1 week. Of course, you won't do it in 1 week, and you will probably never do it because you can only fix things iteratively. If you do it like every day, then you will keep stuff in shape all the time. If you're like trying to do it like once per month, you will get into trouble because it's so much work. The customers don't see any value. You're not motivated enough, and you probably will skip it, or you will not do it right, and all sorts of things. So always just do refactor. Like the TDD process is that red test, then green test, then refactor. So these are 3 steps that you always have to follow. So before writing any code or after writing any code, you just do the small refactoring to improve your whole code base. And if you do it continuously, you will not get into this kind of trouble. So it's continuous instead of big bang. Because and you don't have to never have to ask for permission from the managers, customers, whatever, to do the basic hygiene, because refactoring is the basic hygiene in the software projects. And no database migrations. This is something that I see in maybe bigger, older organizations very often, is that they have this holy database. And holy database that nobody knows how to recreate from scratch on your own machine or whatever. So they always talk about, okay, let's copy production and then try to obfuscate the data. And then they spend half a year trying to do that right. And then they realize that they have personal data in their primary keys, and they are completely screwed. So you always need to, when you start your project, of course, this is very hard to fix when it's gone out of control. But when you start your projects, always have a reliable script and way, step-by-step way how to recreate your database from zero. And if you verify it in your continuous integration, so that every time you run all the tests, you recreate your database and then you run it on your own machine, so you don't waste a lot of time. Because with the holy database approach, it work on it, and they are breaking stuff. They are wasting each other's time and whatever. Yeah.
I think your mic is off. So can you try to turn it off?
Okay. This is like fixing anything in IT. So can you turn it off?
Yeah.
Turn it on again.
You've been in the game for long enough, I think.
And it doesn't work. Okay, thank you. Maybe that was dying. That's why it was like making the loudness tricks. So yeah, so don't do the holy database stuff. And if you are in there, try to like fix it somehow. Usually it's also about the generating of data, which is good enough for testing anything. So I've seen that even if you can copy the structure of the database, there's a lot of logic is embedded in the data. And that is also something that you should avoid because it's very hard to test automatically. So don't put logic into the data. Code is meant for logic, data is meant for data. It's much better that way. So the same problem also with microservices. So if you have too many of them, then you can never run them all on your own machine, and you need to access holy microservices that are somewhere centrally deployed, and then of course they maybe don't work, and then you cannot do your work at all, and all kind of troubles. So every developer should easily run everything on their own machine. I like writing code in an airplane completely offline. So if I have my database, if I have all the stuff that I need on running on my own machine, and I can spin it all in like a few seconds, then I can develop anywhere. So I then don't need to a reliable internet connection, whatever. I can go to the forest like developing or an airplane. So I will be doing that tomorrow, most likely on an airplane. So, and if you have the Colio database, it's very hard for you to do the real good integration tests, which really test stuff in isolation in this database. So basically, if you even try to do some tests on one instance of the database that everyone shares, then again, like you get all the disadvantages of interfering with other people's work. So Docker Compose, really good tool to run all your dependencies on your own machine, just like that. Most of the containers spin up very quickly, including the database ones, and you just run everything on your own machine. So, and the last one I think I'm going to talk today is the slow builds. So people often think that, well, what's the problem with slow builds? I have a server doing the builds for me, and it's not a problem at all. So I'm not waiting for it. So I just commit my changes, and 30 minutes the build takes, but I already work on my next feature. That's all cool. But what if the build fails after half an hour? You need to go back to the last thing you were working half an hour ago. You need to switch contexts. Maybe you switch your branch. You go back to the old stuff, try to fix it. Okay, fine. I found this small mistake. I am just going to fix it and commit and push it. Then I go back again to my next task. And then after half an hour again, it fails again. And then I need to go back and fix it again. And I can never actually be sure that I can completely focus on the new thing before I get the green build. And if the green build always takes time, and at some point I've seen the integration tests taking 4 hours, for example. So it's almost impossible to keep them green 4 hours. If you have like a sizable team, like, I don't know, 10, 20 people working on a code base, they are committing, changing something all the time, and you just never get a green build, because every time you fix something, there is a new breakage introduced, and it takes 4 hours to learn it. And it's just like you're wasting your time again and switching focus and whatever. And you never get in a good enough situation to actually release it to production. So people think, okay, maybe it's okay if we have like maybe 10% of the tests are not green. Maybe we can still go to production with that. And that's not a good situation to be in, because your end users will be paying for that mess. So yeah, slowness can come from slow downloading of a lot of dependencies. So usually in the builds, it's easy to optimize and cache them, work on that. Then slow compilation, like maybe split into smaller modules, not microservices, but modules. Then slow tests, you can always make the tests faster. So you always need to write most of your tests as unit tests, which just test the code. And you need to do integration tests, only like a much fewer of them, so that the slower tests, they are not multiplied every time you want to test a small piece of logic. So that also means that if you're testing your code through the HTTP request, for example, then it's better to test it still on a class level, code level, and keep the HTTP, like the whole stack tests to the minimum. So these are only like testing the whole thing together. And slow startup, that's also a huge thing. So if your application starts a few minutes every time you run it on your machine, and I've seen such projects pretty recently, then you are just wasting your time all the time. So some of the changes require restarts, and you just need to wait over and over again to be sure that the code change that you have just done, you spend like 5 minutes waiting to verify that actually it works, and that's not a good thing. It will slow you down. the turnaround is actually important. There is a company, there was a company in Estonia, Zero Turnaround, that tried to fix it, the slow startup problem for enterprise developers who don't do the good job. So basically, they were trying to reload your code in place and whatever, all kind of very difficult and hacky tricks, just to make you avoid going and making your code start faster. So it's not a big deal. Don't use like frameworks or something that take a lot of time to initialize. Use simpler things that don't need that initialize stuff in background, whatever. The turnaround is important, and seconds actually add up during the day. So if you have slow startup, slow tests or whatever, put the chess clock next to your computer and start measuring time. How much time does it take to you to do your work, and how much time do you spend waiting? So you will probably be surprised how much time do you waste per day. So it pays to, sometimes you need maybe just take a half a day and make it better, and you will already be saving a lot of time for your stuff. So, and yeah, and people get annoyed and distracted. So you don't want to deal with stuff, to return to stuff again. And you probably, while waiting, you will start thinking about other things. You go to your Facebook, you start chatting with somebody, and you waste even more time out of your working day. So I think with that, can we please go to the last slide, the real last one? But that's not that important. Is that thank you for listening. I hope you got some ideas. You can improve some of the things, and yeah, I really hope it's a uphill battle to fix these practices in many organizations, but it's really worth trying. Thank you.
Within a bit of questions, Mara, do we have some time still? I think we do. Yeah. So anyone, any questions? Yeah, there, over there.
What do you use instead of Jira?
We use Pivotal Tracker. It's only one of the options, but the main feature of it is that everyone get the same visibility. So you see all the stories that everyone is working on. There is only one source of truth, one view, and not like many different types of views and all kind of stuff. I can talk about it for 1 hour, but that's the main point.
There was over there a question as well.
Specify about the monolith, especially when it has a few submodules. So what about the semantic versions? You told that you can indicate the same version for all submodules, but what about semantic?
Semantic versions is a good solution to the problem that you should not be having. So yes, if you are creating a library that somebody unrelated to you uses, then semantic versions is a good way to indicate the breaking, non-breaking changes, and that's whatnot. But if you're writing library for yourself, basically, then you should not be doing it. You should not be keeping this code that you don't need anymore, but you just keep it just because you need to deploy them at the different times.
Daily code reviews. It was very interesting. I never used it in practice. So yeah, usually I defer to pair programming as the way to avoid PRs, right? But the daily code review, do you do it when you don't do pair programming, but you, let's say, work on different stuff individually, and then next day in the morning, let's say, you review the previous code?
We use it even if there is pair programming, not in every team. So it depends how the team feels, what type of changes are done. But usually the thing here is that everyone gets into the loop. So the biggest value from it is not the review, but just letting everyone know about what you're working on and which new abstractions are you creating in your code and something like that.
The team, you have 4 people, you would have 2 pairs, let's say, per programming, but then the next day you would review each other's code just to get acquainted with the whole.
Yes. But if, for example, next day we will switch pairs, then probably we will not needed because anyway, I will be working with different person on maybe on a different feature that he or she was working the previous day. So I will get to see it anyway. So with 4 people, often it's not needed yet. With 6, 8 people is already a valuable practice.
Cool. Yeah, one over there.
One more question about daily code review. How much time does the team usually allocate for it?
Depends, something like from like 15, 20 minutes. So if you do it daily and you have done it many times before, you know how to do it quickly.
An interesting observation about code reviews. So I got to work with a number of teams, and I got to work a lead of a number of teams. And like what I usually do with the new team is that I propose the team to choose the the practices and the process, just to like for everyone to kind of choose their own means to do the work. And what I notice usually, like down the road, everyone is hating code review system because it's taking time. No one wants to do them. It's taking time to get back to them, etc., etc. Exactly what you said. But when we kick it off, it's like and I asked the team that, so what do you think, guys? Do we do code reviews? Everyone's like, yeah, we should do code reviews. Why do you think is that?
Because if you don't do them, then it is hard to like share the knowledge, especially if you're not pair programming, and people always think that they are better than the others in writing code, and they have always something to comment and feel themselves important. So that's why people initially like the idea, but then they understand the burden, and it's like it's not giving the value like big enough for them to actually do it. But if you do it every day, if you do it like in an efficient manner, it doesn't take in a scheduled time. You actually, it's not taking your focus out of you, and you do it together. So it's like a collective burden, and you get to talk about things. So even after that, you can like schedule some discussions about some of the features that you have seen. So it's much more enjoyable.
Productivity practice. I wanted to add. So I read a while ago. I read a book called Peopleware by Timothy Lister and Tom DeMarco. So I don't know if anyone have ever encountered Peopleware book. I really recommend. So so there was one thing that they described was that working in small cross-functional teams, which was something that you've kind of slightly touched. So another kind of observation that they kind of emphasized on was that when you have a small team, say like 2, 3, 4 people, right? And then you basically, the team is responsible for the entire, piece of product or the product end to end, right? Then what happens is that their focus time and discussion time actually matches. So basically, what happens that they gather around at the whiteboard. They basically pick a problem, discuss it, define a solution, pick up tasks, go to work, split, get these pieces done, and then repeat. And this basically like all this kind of daily plannings, weekly plannings, whatnot plannings, groomings, whatever, basically all fades and a natural cycle of work process emerges.
I think we like we are definitely observing that in many projects. Yes.
One more about remote pair programming. So, well, I remember I discussed with you a while ago about using different tools like Tuple, but I wanted to ask if it evolved over time, at least for you. IntelliJ now, introduced the whole set of tools. Maybe there are some other ones. How is that experience for you, remote pair programming?
Unfortunately, the bandwidth of remote pair programming is not good enough in reality. So sometimes our people do that, but it's not as enjoyable experience as usually sitting next to each other. So when you have to work remotely for a longer time, you have to maybe agree on like a different way of doing it. Maybe in some cases during the pandemic, we also done it so that we don't pair program all the time, but we push really small commits really often so that the other person sees them with a really short feedback loop and can like react in chat or whatever, or even do the fixes. That worked a little bit better. So sometimes, of course, for like more difficult things, you still need to pair, and screen sharing is something that works still the best. So it ensures that you are seeing the same thing, because all the IntelliJ built features, they unfortunately don't give you the full picture.
Over there.
So I remember when Codeworm was a host for Devclub, there was some presenter from Bolt, product manager, I guess. And his point was to you need to start really fast because you need to gain some profit to continue your project. And I was on the other side of opinion that if you go really fast, then going faster will be much harder because there's a lot of tech debt you collected. So you was on my side, but at the same time, I understand this bold product manager because initially you don't have so much money profit to pay people for some months. Initially, you need to gain it, and how you can when you start new project, how you balance between the tech debt and some really good approaches in.
It's a good question, and as always, the truth is somewhere in the middle. So basically, you still definitely, in terms of business, you need to go fast. In order to go fast, you go with small steps, and you can still make your steps good. So you don't have to accumulate too much of technical debt. So if you know that now I'm experimenting, you can probably skip something for experiment. Like, for example, you mock up a UI and you show it to your customer or whatever, and to end users, you validate if it's good enough, and then you implement it fully. And then you spend already a little bit more time making it well. So you still can move really fast, and we really do it. But the thing is the small steps.
I also wanted to share a piece of insight regarding testing software. I am a strong advocate of software testing, automated software testing, and so like long time, or I think the prevalent opinion on software testing is this proverbial pyramid, where you have the foundation of unit tests, and you have integration and system tests on the top, right? And this is kind of the traditional take, which kind of pushes that, okay, you should write a lot of unit tests. So what I don't remember where I heard it or read it, but so an alternative approach to it is that one should test something that is either really complex or complex enough, or something that is anticipated to change enough. Something that's like, you know, that this piece of integration or this piece of code, you just write it once and it will stay there forever. You're not going to ever touch it again, and it will never change. It is enough to just test it manually, see that yes, it does work indeed, and leave it there. Same goes with some trivial stuff. The function that, you know, takes two arguments and just, you know, sums them up together. Do you really need to automate an automated test for that?
If it's written in dynamic language, then definitely you do need, because you will just type an extra character there accidentally. It will break your production. But I kind of agree that trivial things, or the things that used the most in your software, they are tested anyway. So the most important things to test, especially with end-to-end and integration tests, are the infrequently used features, because these tend to break the most and the easiest, because you're not like going through them yourself all the time. But still, it's better to keep more tests than fewer tests, because even if something is really stable and will never change, it will still change after like maybe half a year. And then you will need to spend time first understanding how it worked before, then you test the previous behavior, and then you change it and you test the new behavior, and then you will have to spend more time like trying to understand what it did and how it did.
Anything else? Well, yeah, let's take the last one in. And
can you expand on like the shared type definitions? Like how do you really structure this? Like what did you mean about that? Because that's like really like a hard thing to do. Like these things break when it floats, for example.
So shared type definitions between backends and frontends. So if, for example, you write backend and frontend in a similar language, like, for example, you have a Node.js backend, it's very easy. You just create a TypeScript definition, for example, and you import it from both your frontend and backend. So that's like the easiest way how to do it. If you're using different languages, then it's pretty easy to do the conversion. Actually, in Codeborn, we have written a couple of open source tools to do that between Java and TypeScript and Kotlin and TypeScript. So basically, you just generate like any classes, like data classes on backend, for example, you just generate TypeScript definitions with the same fields and whatever, and just keep it in one file from where you can import it in frontend and always see what is the current structure of this request or response class, for example.
Because it doesn't seem like a reasonable thing to do, like database models, like ORM models usually go leak into the domain models, and from there.
No, it doesn't have to be like that. It's not about leaking, but it's about actually moving fast. So if you want to move fast, you don't transform your objects 3 times before it gets to the end user. So you start by actually using the same abstractions than you have on your backend. You use the same abstractions in your front end, and that's how you prototype quickly, but you still get a high quality code that follows all the good practices, but you just have much less of that code. When your UI and the backend structure start deviating, then you create new classes that you like the how do they call, like DTO objects or whatever, that already correspond to the stuff that you return from your API calls, and then in the front end you use those classes which the API calls return, and then you're not leaking this stuff from the backend. You're just keeping the structure the same on the edges of both worlds.
It was very insightful. Thank you, Anton. Always great to have you. And dear guests, that's it for tonight. Thank you so much. Thank you so much, Wise and Mara in particular. It's a great one. Let's see you in a month, hopefully. Right. Just was nice.